Do you get confused by a lot of the rhetoric around scientific studies and which ones should we believe and which ones should we push aside? Well, you're not alone. So I'm Dr. Tracy Tyson. I'm a board certified general pediatrician, and let's talk about the statistical power of studies and why one study can look really concerning or really hopeful, but when it's put into a big bucket of other studies, it doesn't look so much. So this is a perfect example. This was a study that was done in Denmark in 2015, and it was a cohort study, meaning they just grabbed data. They didn't do any investigation of their own, which is a common way to start with epidemiological data, where you just start pulling information. Is there anything that sticks out? And then further research needs to come on top of that. So a really common place to start with the scientific method is to look at demographics. Is there anything that sticks out that could possibly be something that needs to be looked into further? So that's what this study showed. And they found when they looked at epidemiological factors, which are factors about the people in their community, that there seemed to be an increased risk of autism under the age of 10 in boys who were circumcised versus boys who were not. So why have we not been talking about this more? Why hasn't this been discussed? Why is your doctor not telling you not to get your son circumcised? So let me explain this. The way that scientific research works, as we talked about, is people kind of throw a casting net out and they're like, hey, this is a subject we're really interested in. We don't know exactly where to start. So let's see if there's any environmental factors, medications that someone took, infections while they were sick. Is it increase in certain races, religions, for circumcision, any of those things. And if you notice there's a bump in something in a population, then you need to look at it further. So there's something called a meta-analysis. A meta-analysis is where the researchers take every study that they deem to be appropriate, and this one is, and they put it all together and they try to deal out, can you repeat this? Is there any other studies in any other places that show the same thing? And is there anything that negates it? So the statistical power, meaning how likely is it to be true, is about 50 times higher in a meta-analysis than it is a single study, for very good reason, right? So that's why sometimes a single study is a great place to start and is so important in the scientific method, but it is not the whole story because it cannot look at every other factor. If you're looking at a population, and this is mostly a Caucasian population, which is really likely to have autism as well as to be circumcised. Therefore, when you have some things that are so highly prevalent, you are more likely to get something that looks causative, and that doesn't mean it's related. We also have to remember little things like people who are more likely to get a circumcision are more likely to take their child to the doctor to be evaluated for autism. So again, it's not a bad study, it's just not the whole picture. And when we make recommendations to the general public, we make them with statistical power. So something like a meta-analysis is going to be much better at making recommendations than a single study. They're good places to start, but it's not the whole story. So I hope this helps a little bit. I know this is hard to understand because there's so much information out there. It's not that there's some science that's just not believable. Some is not good science, but some of it is just not the whole story, and it's a place to start. So the more you know.